Greetings everyone, my name is Eugene Mangundu and I'll be doing the presentation for Natural Science and Health Education for year number 3, semester number 2. So I'll prepare you for the exam, so the exam for April, August and the supplements for November. Alright, so let us move on to the next slide and see what it says. So this is what I've said before. So it's an exam for April, August, November. And then there's a question here. Why do we need this presentation? So we need this presentation so that we can prepare for April, August, and November examinations. So there will be no. This is the only presentation that we are going to have. And I'll also go through the old question papers from previous papers. Alright, let's move to the next slide and see what is there. I want you to remember these verbs. They are very important. Okay, you need to know how to answer these verbs. Okay, if you go through your study guide or through your course outline, these verbs are defined. So I want you to acquaint yourself with the definitions of these verbs. So if you're asked to contrast or define something, you should know what is expected of you. And if you're asked to discuss, you need to provide more info compared to when you're asked to define. If you're asked to distinguish, which is the same thing as differentiate or contrast, so you highlight the difference between the two things that you are asked to distinguish. On the other side, if you're asked to deduce simply means you must use the given information so you can come up with a conclusion or with the answer. And illustrate, you provide a very simple diagram that will help you to give the answer. And then outline, if you're asked to outline, you simply write down in bullet form the points. So outline, illustrate, mostly used for when you're asked to when you are dealing with a system. Let me say you are asked to list down the steps needed if you are balancing a chemical reaction or a chemical equation. So you need to write down the points, what you do first, secondly, and then thirdly. Let us move to the next slide. General expectations. What are you expected to do when you sit in that exam? You need to spell the scientific names correctly. I gave an example of potassium. Potassium is double S, not double T. Most students make mistake to put double T instead of double S. So you should spell the scientific names correctly, please. You should do that. You should also remember the names of the apparatus, of the equipment. So what you need to do, maybe go through your study guide or go to the internet and try to see if you can get as many apparatus or equipments with their names, correct names, please. Balanced chemical equations. I understand this is one of the painful things that students find, but I'll try my best so I can help you how to balance chemical equations. I don't know which method you use, but I guess my method is going to work. Let's quickly look at this one. So let's have nitrogen gas reacting with a hydrogen gas. It will produce ammonia. Alright, so this is N2 plus H2. That will give us NH3. Now, looking at this equation or chemical equation, as we can see, we have nitrogen is 2 this side, but nitrogen this side is only 1, and hydrogen this side is 2, and hydrogen this side is 3. So meaning that our chemical equation is not balanced at all. So how do we balance this? We should look at our main product. Our main product says for 1 nitrogen we need 3 hydrogen. All right, so the ratio says the ratio is 1 to 3. For 1 nitrogen we need 3 hydrogen. Now if you look at our left hand side, we have 2 nitrogen. So what if we have 2 nitrogen? How many hydrogen do we have? Remember, the ratio says it's 1 to 3. So what if we have 2 nitrogen? So I guess we are gonna have 6 hydrogen. How did we get the 6? You simply multiply the 3 by the 2 to get the 6. So we need to have 6 hydrogen this side. So we put a 3 here. Let me use a colored one, a black one. So we put a 3 here so that 3 times 2 is 6. All right. So, but on our right hand side, we still have 1 nitrogen. We need to make them 2. So we need to put a 2 in front of our ammonia molecule. So 2 times 1 is 2, and 2 times 3 is 6. So meaning that our equation is now balanced. So you make use of the ratio to balance a chemical equation. So, and you should always look at the main product. Okay. We can recycle this. All right, let us try another one. So that was very simple. Let's try another one. We have hydrochloric acid, and then we add magnesium oxide. What are the products? We have an acid and we have a base. So this is a metal oxide. So we are going to have 2 products. We'll have a salt plus water. So one of the products will be water. So the salt will be magnesium chloride with a 2 there. So that's our equation. So it's hydrochloric acid reacting with magnesium oxide to give us magnesium chloride, the salt, and water, H2O. Now let us look at this equation. Is it balanced? So let us start with hydrogen. Hydrogen this side, we have it as 1. Hydrogen this side, hydrogen this side is 1. Hydrogen this side, we have a 2 there. There is a 2. Chlorine this side, we have a 1, and chlorine this side, we have a 2 there. And then we go to magnesium, Mg is 1. Magnesium this side is 1. Nice. So magnesium is balanced. Then we go to oxygen. Oxygen this side is 1, and oxygen this side we have 1 as well, because it's just 1 here. Remember that this 2 is only for hydrogen, is not for oxygen. So this 2 is for hydrogen, not for oxygen. This 2 is for chlorine, not for magnesium. So that's why it's 1 on 1 for magnesium. For chlorine is 1 to 2, and oxygen is 1 to 1, and hydrogen is 1 to 2. So the hydrogen and the chlorine are not balanced. We are going to balance them. So where do we start? We should look at our main product. Our main product is a salt. Every time you have an acid-base reaction, your main product must be the salt. All right, so the salt says for every magnesium we need 2 chlorine. So 1 magnesium should give us 2 chlorine. So, but now this side we only have 1 chlorine, so we need to make sure that there are 2. Okay, so this side we have 1 magnesium, we are sorted. But the chlorine, there are 2 this side, there's only 1 here. So we must put a 2 here in front of the acid so that we have 2 chlorine and 2 chlorine. If you look at oxygen now, hydrogen, so chlorine is now 2, we remove that 1, we put a 2 here. And hydrogen, the 2 that we put in front of hydrochloric acid, this 2 is also for hydrogen. And remember that on your right hand side, hydrogen is also 2. So hydrogen is also now balanced. So our equation is now balanced. Hydrogen 2 this side, hydrogen 2, chlorine 2, and also chlorine at 2 here. And then magnesium 1, 1, that's fine, oxygen 1, 1. So our equation is now balanced. One thing I want you to remember is the number that we put in front of a compound. That number belongs to every element in that compound. If you put a 3 here, the 3 will be for hydrogen and it will also be for chlorine, but not the rest. Only for the molecules or for the elements where you put the number in front. Okay, so we can do a lot of balancing chemical reactions. Please, I'm going to leave my number at the end of the session so you can come through to me so we can have a look at them if you're still struggling with this. Okay, so let us move on to the next one. The next one says you need to calculate molecular mass. So the molecular mass, how do you calculate the molecular mass? Get rid of this. So the molar mass, it's abbreviated like a capital M and a small r. So you read it as molecular mass. How do you calculate the molecular mass? So let's say we are given sulfuric acid and we want to calculate its molecular mass. So where do we start? We know that the mass of hydrogen atom is 1 mole per, it's 1 gram per mole, and the mass of sulfur is 16 gram per mole, and oxygen is 16 grams per mole. That's for oxygen, and for sulfur it's 32, not 16. So this is 32 grams per mole. Where can you get these numbers? You'll be provided with a periodic table of the elements, or if there's no periodic table at the back of the question paper, these numbers will be given for that specific question. All right. Now, if you look at our formula says if you want to make sulfuric acid, you need 2 atoms of hydrogen, 1 atom of sulfur, and 4 atoms of oxygen. So this 2 is only for hydrogen, and this 4 is only for oxygen, but not for sulfur. So this 2 is not for sulfur, it's not for oxygen, it's only for hydrogen, and this 4 is only for oxygen. So we say, since we need 2, we are going to multiply this by 2 because there's a 2 there. So we say hydrogen is 1 times 2. Sulfur will be just 32. And then oxygen will be 4 by 16. And then we sum them up. So this is just 2, this is 32, 4 by 16, so it's 40, that's 24, so it's 64. Alright, and then we add them up. This will give us 8, and that's 9. So the molar mass of sulfuric acid is 98 gram per mole. So these numbers, they will be given to you in the exam if there is no periodic table at the end of the question paper. All right. You'll be also expected to calculate the number of neutrons. That is the easiest of them all, to calculate the number of neutrons. How do you calculate the number of neutrons? Let us take potassium. Potassium is capital K and 3919. So this is your MR, and this is the number of protons or the number of electrons. How do you get the number of neutrons? So the number of neutrons, NO, would be 39, then you take away 19, that would be 20. Very simple, very, very simple. You'll be expected to draw an atom. How do you draw an atom? So let's say we want to draw the atom of potassium. So before we draw the atom, you should always write down its electronic configuration, or the arrangement of the electrons. How are the electrons arranged in the shells? So 2 in the first, 8 in the second, and also 8 in the third. Potassium has about 4 shells, but these are only 3 shells. So this is the first shell, second, then the third. And as you can see, you have already used up 18 electrons, because 2 plus 8 is 10 plus 8 is 18, so we need an extra shell. So meaning that potassium has 1, 2, 3, 4 shells. So you start off by saying, this is my nucleus, the center of the atom, and then you draw the first shell. You can either use crosses or dots for your electrons. My second shell will contain 8. This is very basic physical science, very basic, so I expect everyone to get this right. And then of course the last shell will take up only 1 electron. And then you say, now my nucleus is made up of 19 protons and 20 neutrons. You can do that. So that's how you draw an atom. All right. You are also expected to recite correct formulas. Okay, so you'll be given a chemical equation in words, and you should write it down, or you should write it down in using the symbols. For instance, what we did at the beginning, remember when we had nitrogen gas, hydrogen gas to give us ammonia. So this is the word equation. You should now write it in a chemical, it's a chemical equation. A chemical equation doesn't have words, it's just the symbols. So you need to remember which letter is for oxygen, which letter is for potassium. You need to remember all these letters for the exam. And please use correct units. If you are calculating moles, there is no way you leave your answer as grams. Your answer should be in moles. And you should be able to use the periodic table of the element. Alright, let's move on. Alright, these are the important tips for the 3 examinations. Number 1, you should be able to identify and also know the uses of the lab equipment. So if I give you a picture of lab equipment, you must be able to tell me that this is a mortar and a pestle, or this is a thermometer and it is used to do this and that. You are also expected to convert from between the three scales of temperature: the Celsius temperature scale, the Kelvin, and also the Fahrenheit. So you need to know this formula, how to convert from the Kelvin to Fahrenheit, Fahrenheit to Kelvin, and between Celsius and Kelvin. So you should be able to do that. You must be able to define and also differentiate. Remember, differentiate. You tell the difference between simple distillation and fractional distillation. So differentiate simply means you must know the difference between the two. And then remember the electronic configuration that I was just telling you here. So electronic configuration, some people call it the electron arrangement of electrons in an atom. So you need to know how to write this down. It's called the electronic configuration or the electron arrangement. You must be able to differentiate between atoms from ions. How do you differentiate, or what is an atom, what is an ion, what is the difference between the two? Because they are not the same at all. An atom, it has a neutral charge, but an ion, it has lost an electron or it has gained, so the charge will not be the same as that of an atom. Let us look at a very simple example. Try to okay. Let's look at magnesium atom. Magnesium is 1224. So an atom of magnesium will have 2 in the first, 8 in the second, and 2 in the last shell. So meaning that magnesium is in group number 2, and it has 1, 2, 3 shells. Now for magnesium to have a full outer shell, magnesium should either gain 8 electrons to make this, 6 electrons to make this 8, or magnesium should lose these 2 electrons. So it is going to be easy for magnesium to lose these 2 electrons than to gain. So that's why magnesium will lose these 2, and then it will become an ion. Now, this is an atom. So if you look at the number of electrons, there are 12 protons, 12 positively charged materials, or 12 positively charged particles. And you also have 12 negatively charged. So this is like 12 minus 12, it's just 0. That's why an atom has a net charge of 0. But an ion, so magnesium ion now, should lose these 2 electrons, so they will go. So it will only have 2 in the first and 8 in the second shell, and of course nothing in the third shell. So meaning that it will still have 12 protons, but now it has only 10 electrons. So this is like 12 minus 10, which is positive 2. So that is why magnesium forms a charge of positive 2. So magnesium forms positive 2, and this positive 2 means it has more protons than electrons. Okay. And the last one is you should be able to define isotopes. I find it so easy to define isotopes when you do this. Okay? So the famous isotopes are for hydrogen: 1, 1, 1, 2. Let me use another one. And 1, 3. Alright? So these are isotopes of hydrogen. So where do we start? Isotopes are atoms. 3 are atoms of the same element. So we say atoms of the same element. That is 1 mark. Usually this question is 3 marks or 2 marks. So isotopes are atoms of the same element with same, if you look at this number down here, it's the same. So it's the same with same proton number. They have the same proton number and different. Look at these numbers on top, they are different and different mass numbers. So if this question is 3 marks in the exam, that's 3 marks. So that's how you define isotopes. Write down the isotopes that you know. You can also write down the one for carbon. Carbon, we have carbon 12, carbon 12, 6, we have carbon 13, 6. So as you can see, these numbers are the same, but these numbers are not the same. But they are all made up of what? Carbon. So atoms of the same element, same proton number, but different mass numbers. So that's how you define isotopes. Very easy. Let's go to the next slide. You need to remember the properties of compounds formed by group 4 elements. You need to remember these properties formed by carbon, formed by sulfur, because these are the elements in group 4. You should write down word equations. You should also be able to write down balanced chemical equations. So I gave an example there of hydrochloric acid and lithium hydroxide. So let's quickly do it. Let's try to balance it again, because I know balancing chemical equation it's one of the difficult work for the learners. So we have hydrochloric acid, and then we have lithium hydroxide, so it's LiOH. So it's an acid. It is an acid here plus a base. So it's going to produce a salt, that's lithium chloride plus water. So every time you have a metal hydroxide or a metal oxide, the first product will be the salt, and the other one will be water. Is this chemical equation balanced? Let's see. Hydrogen this side. How many hydrogen atoms? We have 1 and 2, so there are 2. 1 and 2. Then we go to chlorine. Chlorine, it's only 1. Lithium. Lithium, we only have 1 as well. Alright, and then we go to oxygen. Oxygen, we have just 1. On this side, hydrogen, we have 2. Chlorine, we have 1. Lithium, we have 1. And oxygen, we have 1. Wow, so this one is balanced. So we don't have to balance it. It is already balanced. You should also learn how to write out chemical formulas. You'll be given a compound in words, and then you should write down its chemical formula. For instance, you are given this an example there of sodium oxide. Sodium oxide, and you also have aluminium oxide. All right, so you want to write down their chemical formulas, so you need to go back to your periodic table and find out where they are. Sodium is Na 1123, and it's because it's oxide. That was oxygen before they reacted, so it's oxygen, so it's O, 8 and 16. So you write down the electronic configuration for sodium, which is, it has 11 electrons, so it's 2 in the first, 8 in the second, and 1 in the last. So meaning that sodium should lose this electron. All right, oxygen is 2 in the first and 6 in the second. So sodium is in period number 3 because 3 shells, and oxygen is just in period number 2 because it has 2 shells. Now looking at this 6 needs 2 to have 8, which is a full outer shell. But sodium can only give 1. So what do? So we invite another sodium. So we say 2, 8, 1, so that this electron will be transferred, ionic bonding, transferred. So in the end, we have used how many sodium? We have used 2 sodiums and only 1 oxygen. And that is the formula. So that's how you come up with the chemical formula of the compounds. Let us look at aluminium. Aluminium is capital A and small l 1327, and oxygen again it is 816. Let us write down the electronic configuration of aluminium. It's 2 in the first, 8 in the second, and 3 in the third. So it's altogether 13. 10 plus 3 is 13. Oxygen again is 2 in the first, 6 in the second, and that's 8 altogether. Alright, so what do we do now? Looking at aluminium should lose 3. But this oxygen needs only 2. So we are going to transfer this 2 here. 1 and 2 electrons. So these 2 electrons are going to this oxygen. But now we have an extra one with aluminium. So what do we do with an extra one? So we need another oxygen. So we invite another oxygen. 2 and 6. So that the remaining one can now come here. So aluminium is now sorted. It has lost all the 3 electrons. But oxygen, this one is not satisfied because it only got 1. Remember, it must get, after getting the 1, there are only 7, but there should be 8 in the last shell. So what do? We call upon another aluminium, so that 1 electron will be transferred there. Now this oxygen is sorted, this one is sorted, but this aluminium is not sorted. It has 2 extra. So what do? We say, another oxygen please come on board, so that the remaining 2 can now go to you. So we have 1 and 2. So everyone is now sorted. So in the end, what do? We say, I have used 1, 2 aluminium. So it's Al2. How many oxygen did I use? 1, 2, 3. O3. Please, if you have hard time writing down chemical formulas, please, as soon as I leave my number behind, make time for me so we can go through this again. And the second last one says calculate moles and also molar mass. We did the molar mass, so we're only going to do calculate the moles. How do you calculate the moles? You need to remember this formula, that the number of moles is the same thing as we take the mass, we divide it by the molar mass. or simply a small m divided by capital M with the R. So that's how we get number of moles. So you can't get the number of moles if you did not work out the molar mass. So let's say we are given, in that example, we are given calcium sulfate. So calcium sulfate, we are given, let's say we are given 20 grams of calcium sulfate, and we want to find how many moles are in these 20 grams. So first thing, we find its MR. Okay, so calcium, it's 2040. Sulfur, 1632. And then oxygen is 816. So according to the formula, we need 1 calcium, 1 sulfur, and 4 oxygen. So we say calcium, it's 40, sulfur is 32, and oxygen is 16. But now 16 times 2, remember, times 4 because of this 4. So 16 times 4, and then we add them up. It will be 40, 32, 16 times 4. Let's quickly do that separate here. 16 by 4, that's 40, 24. So that's 64. 64, and then we just sum it up. This is 6, this is 100, and that's 136. So the molar mass of calcium sulfate is 136 gram per mole. Alright, so remember, we want to find the number of moles in this mass. So we are converting the mass to the number of moles. So what do? So we know that 1 mole has this mass. Per means it's 136 grams for 1 mole. Now what if I have 20 grams? How many moles do I get? So we just take this number, 2 numbers, and then we plug them into our equation. Our equation says, if I want to get the number of moles, I should divide the mass, which is 20 grams, I should divide that by 136 grams per mole, so that the grams will cancel each other, then I end up with the number of moles. So whatever number you get here, that's the number of moles that you can get in 20 grams of calcium sulfate. You are going to get this question in the April and also in the August, as well as in the supplementary. You need to practice how to do this. Okay? Let's move on. We go to metals and alloys. Very useful metals. You should know the uses of the metals, useful metals. Please, you need to know. You should also be able to define what is an alloy. You must know that definition. More important tips. You need to study the trends in the periodic table. I know it's in your study guide. Alright, like when you move from left to right or top to bottom, how do you compare the boiling points and also the melting points? You need to know these trends in the periodic table. You must use the periodic table to draw atoms. I've shown you how to draw atoms. This is something that you did in your grade 10 or maybe grade 12 exam. And also you need to study or go through soft and hard water. Very important. You need to study this. And then you should also know what causes temporary and also permanent hard water, which compounds, which salts, because hard water is caused by salt. Which salt is responsible for temporary hard water and which one is responsible for permanent hard water? In which town in Namibia can we find permanent hard water and where can we find temporary hard water? You should also know how to remove the temporary hardness of water. It's either by boiling or by using chemical. You need to know this method of removing temporary hard water. And in permanent hard water, there is no way you can remove it because of the certain salt that causes them. And the difference between soft and hard water, which one lathers easily, which one forms the foam. When you put in soap or washing powder in the water, some hard water will not form that foam, but soft water will form the foam. So you need to know the difference between the two. All right, so this is the end of the presentation. I hope you find this presentation useful, and remember, that's my number, that's my email address. Please come through so we can set up a meeting or maybe an extra lesson before you write your exam. I'm willing to help you. Thank you so much.